Hello everyone, and welcome back to the channel. I'm really glad you're here. Today, we're going to analyze one of the most popular low-cost power supply circuits used in electronics, the transformerless power supply, also known as a capacitive dropper power supply. Instead of focusing on assembling the circuit, we'll explore how it works, its engineering principles, important formulas, practical design rules, and most importantly, its advantages and limitations. So let's get started. A capacitor blocks DC but allows AC to pass. That is why a capacitor can safely limit AC current while preventing DC current from flowing through it. One microfarad, approximately 50 to 70 milliamps. 2 microfarad, approximately 100 to 140 milliamps. 3 microfarad, approximately 150 to 200 milliamps. These values are approximate and depend on mains voltage and frequency. A common engineering rule is, if the required output current is below 100 milliamps, a transformerless power supply can be considered. Above 100 milliamps, this topology becomes less practical due to capacitor size, heat, reliability, and safety concerns. The AC mains enters the circuit from the left. Capacitor C1 limits the current. Resistor R1 safely discharges the capacitor after power is removed. The bridge rectifier converts AC into pulsating DC. Resistor R2 limits surge current during power-up. Capacitor C2 smooths the ripple voltage. The Zener diode regulates the output voltage. Finally, a stable DC voltage appears across the output. Important engineering formula: capacitive reactance, where XC equals capacitive reactance, ohms. F equals frequency, hertz. C equals capacitance, farads. A transformerless power supply converts AC mains into low-voltage DC without using a bulky transformer. Instead of reducing voltage directly, it uses the reactance of a capacitor to limit the AC current. This makes the circuit inexpensive, lightweight, and compact. However, the output is not electrically isolated from the AC mains, making safety the most important consideration. Capacitor C1 must always be an X2 safety capacitor when connected directly across the mains. Electrolytic capacitors should never be used as C1. Output voltage depends strongly on the load current. Ripple increases as load current increases. This power supply is intended only for low-power electronic circuits. Advantages: no transformer is required. Ideal where space is limited. Much lighter than transformer-based supplies. Very little power is dissipated inside C1. Simple and economical design. Transformerless power supplies are excellent for inexpensive, low-current applications, such as LED indicators, sensor circuits, timers, and simple control boards. However, whenever user safety or electrical isolation is required, a transformer-based supply or an isolated SMPS is the preferred engineering solution. Practical test. With a 12-volt Zener, the measured output is approximately 13 volts DC without load. Replacing it with a 7.5-volt Zener gives an output close to 7.8 volts DC. This difference is completely normal due to component tolerance and load conditions. Disadvantages. The output is directly connected to the mains. This is the biggest disadvantage. Improper handling may result in electric shock. Not suitable for high current applications. Output voltage changes significantly with varying load. Input voltage variations affect output performance. Without R2, inrush current may damage components. Not recommended for microcontrollers, communication modules, USB devices, or equipment requiring isolated power. Thank you so much for watching this video. I hope you found it useful and learned something new. If you enjoyed this video, please give it a thumbs up, subscribe to the channel, and turn on the notification bell so you won't miss future electronics projects. See you in the next video.